Two methods for item discrimination analysis in SPSS for MCQ exams. Those two methods are, first one is Kelley's equation method. The second one is Point Biserial Correlation coefficient. Item discrimination analysis in SPSS based on Kelley's equation. The analysis will evaluate and identify multiple choice exam questions that are good or bad in discriminating between high performing students and low performing students. So this analysis is only designed for multiple choice questions, and the analysis is based on an equation generated by Kelley's to determine the item discrimination or the question discrimination. And the way to do that is to calculate the total scores for each individual participant achieved in an exam, and then group the student into an upper group and a lower group. The upper group contains top 27% of the total score, and the lower group includes lowest 27% of student total scores. And then proportion can be calculated for the upper and the lower, and a percentage can be generated for each individual item or question. And the value for the item discrimination can be from -1 to +1. Here in this SPSS data view, I have a result from exam and the test for 20 students participated in this exam that included in it 20 questions, 20 multiple choice questions from 1 to 20, and each individual student answered the multiple choice questions, and their answers are recorded as either 0 or 1, given a value of 0 or 1. 0 represent wrong answer, 1 represent correct answer. And from those 20 questions, we aim to determine which one of these questions are good questions and which are bad questions, in distinguishing between excellent students and low performing students. And to do the item discrimination analysis, it is a multi-step. The first step is to calculate the overall mark or the total mark achieved by each individual student, i.e. to add up all the correct answer recorded by each individual student, add them up and generate a new variable, call it total score. And to do that, we click on transform, compute variable. In this new window, I'm going to generate a target variable, call it total score. And in the total scores, I'm going to add all the values within each individual cell together. So i.e. add all these multiple variables for each individual student together to generate the total or overall mark. So we need to use the sum function in this case. And the sum function, to get the sum function, click on all, scroll down to statistical, and then click on sum, drag the sum command into the numeric expression. A numeric expression, the sum is followed by a bracket, so we need to enter or transfer each one of these questions or variables into the bracket or between the bracket and separating each question by a comma. So if you click on the first one and then add a comma, click on the second one, transfer, comma, and then third one, and so on. And since we have here 20 exam questions, I had already generated these questions labels in Word document, type them, and I'm going just to select them and copy them and then insert them or place them in between the brackets. So if I delete that, add the bracket again and Control V or paste. So all the 20 variables have been placed in between the brackets separated by a comma, and this will instruct the software to add all the values for each individual student, to add them up together and generate a new variable called total score. If we click on OK, again we'll see here that a new variable is generated called total score that has in it the overall mark achieved by each individual student. And I'm going just to edit the column a little bit by removing the decimal point and making it 0, making it at the center, and then since it is a marks and this is a scale, it's measured at a scale, and then I'm going to reduce this, keep this up to 66, so to reduce the column. So now to continue with the item discrimination analysis, we need to rank those overall mark or scores in a descending order from high to low. So we're going to click on data, sort cases, and we are going to sort the cases by the total score and in a descending order from high to low. Again, as we can see here, the data are rearranged that we have the highest score achieved by student are 17 out of 20 and the lowest is 8 out of 20. The next step in SPSS is to rearrange the data to be able to manage to calculate the upper group and the lower group. So we are going to use a function called transpose, in which we transpose these questions from being in a column into a row and swap the students' numbers and IDs, swap them from rows into columns. So it is a reciprocal swapping. So if we click on data, scroll to transpose, and then we are going to transpose all the variables with even the total score into the box of variable, and we're going to name the variable, move the student ID into name variable, and if we click on OK, a new window appears showing that the questions has been transposed into rows and student IDs had been transposed into columns. Again, as this is for question number 1, 3, 9, 19, and 2, similar to the original 1, 3, 9, 19. It's just only it has been transposed. I'm going to do a little bit of editing here as the width of the column is large, so I'm going to reduce it a little bit to do a little bit of editing. So I'm going to change first of all the decimal into 0 for the copy for all the data we have here, for the value of the the value or the scores within each cell. And going also to change the column width as it's too high for 12, so we'll keep it at 6, give it a 6, and this is also 6, and see if I can copy it, and if I can drag it and change it for all, if I click Control V, again it has changed the column to 6, number 6, and again align them into the center, so keeping the data within the center of the cells. And for measurement, we're going to change that into scale. For all the data. So when we look at the data view, it is much neater and much better. We could reduce it more, but that's more than sufficient. Again, if we look at the total score, the order and the rank is kept also constant, hasn't been changed since we have done the ranking. So now we have first of all calculated the total score, ranked the data, and then transposed the data. The next step is to group these students into upper group and lower group and calculate the proportion in each. And for the upper group, it should contain top 27% of the student total scores, and the lower group contain lowest 27% of the total score. And since we have here 20 students, and if you use a calculator, though we don't need a calculator, it's just only we have here 20 students, and we need to generate a group that has 25%. So we will multiply that by 27%. 27%, that will generate 5.4. So we will convert that to integer. So we will put in the upper group 6 scores, overall scores from 6 students, and in the lower one overall scores from 6 students, again in the low performing student. So in this case, so we're going to generate upper group that includes 6 overall grade from 6 students, and the lower one overall grade from another 6 students that are performing poorly. And the way to do that is to generate again here a variable, call it upper group, lower group. So compute variable, generate a target variable, call it upper group, and the upper group, again we can see here the order is and the rank is kept in place. So K1, as we can see here, is the highest mark or the highest total score here. The first 6 has the highest total score, so we're going to select 6 from K1, 1, 2, 3, 4, 5, 6 up to K4 here. So what we will do here is to click on brackets here, move the first value from the variable K1, and then add a plus sign, then add the second one, and then another plus sign, a third one, a fourth one, a fifth one, a sixth one. So we have here top grade or top overall scored from the top performing student. So this is the upper group, and we're going, since we have selected 6 students, divide that by 6. And if we click on OK, a variable generated here for the upper group for all the 20 students and the 20 questions. Now, to generate the lower group, we're going to do the same thing, but we're going to select the lowest 6 scores. So here are the lowest 6 from 1, 2, 3, 4, 5, 6. So starting with 7, moving 7, adding plus sign, and then this variable, plus sign, this variable, and then the next one. We haven't moved the 11th. And then we move the other one. And then the next one, and finally the last one. So we have here 1, 2, 3, 4, 5, 6 variables moved into between the bracket, and we need to add them up and then divide them by 6 to calculate, to generate the lower group. So here we are calculating the lower group, and if you click on OK, and again another variable is generated called lower group. The next step in generating and calculating the item discriminating IT is to subtract the value from the lower group from the upper group. And again, to do that, we click on compute variable, and I'm going to reset that and call it ID. And instead of retyping the whole thing, you just click on upper group, put the minus sign in between, and then lower group, and then click on OK, and ID or this item discrimination is generated here. We're going to ignore the value for the total score from our calculation, but what is genuine here is that this is the ID score, and the ID value should be between -1 to +1. So we could see 0 value here, and as we can see here, a 0 value, and a 0 value here, and a minus value here, and a positive value of 0.5. So if we take the first example here or the second one, -0.17. -0.17 indicate that there is something not correct with the question. The question is, in this question number, let's say, which question is this? Question number 2. Low performing students are answering the questions correctly, and high performing students are answering it wrongly. So this question has to be removed from the exam, as it is not discriminative. It does not distinguish between high performing and low performing. Now, the other thing is that also the question number 3 has a value of ID value of a 0, and that is indicate that this question is not discriminating between high performing or low performing, as they both scored the same on this analysis, ID analysis. Again, the same thing for question number 4. If we scroll down here, again, this is a question number 16, and if we show from question number 16, it has a positive value, and it is 0.83. This is a very high value, which indicates that this is a very good question, that it can discriminate between excellent students and poorly performing students. So anything, the rule The rule for ID analysis, the rule for it that anything above 0.25 up to 0.39 is considered to be a good question. Anything above 40%, 0.4 and above is considered to be a extremely good question. So this question is extremely good. This question, again, this question, though it is positive, but the score or the value for it is 0.17, which is less than the standard. The standard for classifying questions has to be above 0.25 and above to 0.39. But in this case, it is below 0.25. Thus, this question is a poor question in discriminating between high performing and low performing. So this question is poor questions. This question is a poor one. This one is a good one, very good one, very good one. This is good. This is bad one. This is good, very good, very good, good, and so on. So this is the way to do item discrimination analysis in SPSS for a multiple choice questions, and it is of a great benefit and use for those who designing an exam or an assessment for students and want to evaluate the power of discrimination of the questions and ability of the questions or the item to discriminate between high performing and low performing students. The way to do that is, one of the way to do that is to do an item discrimination analysis based on the formula formulated by Kelley's equation. So the way to do that is to rank your data into according to the overall scores from high to low, and then in SPSS rank them. First calculate the total, then rank them, then transpose your data, and then calculate the upper group proportion, lower group proportion, and then subtract them from each other to generate the ID. We could also, in addition to calculating the ID in this way, we can also generate an ID percentage. The way to do that is to go to compute again, and we are going to call it percentage. And to do the percentage is to select the ID, drag it here, and then multiply that by 100 to get a percentage for the item. Again, as we can see here, this item is 83% discriminative. So this is the way to do item discrimination analysis in SPSS using Kelley equation. Good or bad MCQ questions. Whether you are an educator, a teacher at school, or a lecturer at college, or a professor at university, and you are frequently involved and participate in exam questions design, and you repeatedly design multiple choice question exam paper, and you want to look at the questions and determine which one of these questions are bad and which are good, which of these questions discriminate between the student of high performing student and low performing student. The way to do that is to use item discrimination analysis or question discriminating analysis in SPSS based on using a point biserial correlation coefficient. A point biserial correlation coefficient is a statistical test that is used to find the relationship between two variables or two sets of data. And I'm not going to describe the background and the criteria and the conditions in which to use the point biserial correlation coefficient in it, as I've already described it in a separate video, and I have uploaded that on my YouTube channel, and I'm going to leave the link for the video in the comment box, so feel free to have a look at it. But here I will just show you how to do the statistical test and how can you tell and determine and identify a good question or a bad question. Here in SPSS I have a data for an exam question for 38 students answering 76 questions, multiple choice questions. So we have here 76 variables, 76 columns, or 76 items. These questions can be called items also. And the score or the value for each question for each individual student answered is recorded as either 0 or 1. 0 stands for wrong answer. The student has or had answered the question wrongly, and 1, the student had answered the question correctly. And to determine which of those questions are good and which are bad, we need to do a statistical test called point biserial. But we need first of all to do 2 steps. The first step, we need to calculate the overall total mark for each participant or each student achieved. So we need to generate a column here for the total overall exam mark or total exam score for each individual student. So we are going to generate a column here for that, and we are going to calculate that in percentage. So we're going to add all the scores or the value for each of those 76 questions for each individual student, add them together, divide them by 76, and then multiply them by 100. The way to do that is to click in SPSS, to click on transform, compute variable. Again, there are 3 ways to calculate the total exam score or the overall exam mark. First one is you click on bracket, drag the first variable, click on plus, second variable plus, and then plus, and so on until you move all the questions in between the bracket from question number 1 to 76, and then divide that by 76 as we are adding them up, and then dividing them by 76, and then multiply them by 100. So this is one of the way to calculate the total exam score. The other way is to click on function group all, then scroll down to statistical, and then from statistical choose the sum command and drag it to the numeric expression. Again, you have the sum command and then a bracket, and we need to move the first variable separated by comma, second variable separated by comma, third variable separated by comma, and so on until you enter the 76 variables in between the bracket. Then you need to divide that by 76, multiply that by 100. So this is the second way. The third way, which I am going to use here, is to use the mean function. Again, so we need to generate a target variable. We're going to call that target variable over all marks. Overall marks, and again we're going to move all the scores, all the variables, all the items and with their score in them into the bracket one by one, separated by comma to generate the mean. So we have here 76 items or variable, and I had already typed this in Microsoft Office, and I'm going to copy it from here, right click and then copy, and then paste it into the in between the brackets, so to save me time, so they are there to use whenever I need them. So here we have the mean, and in between the bracket the variables or the items from question number 1 to question number 6. And to calculate the overall mark, i.e. the percentage, I need to multiply this by 100. As of already here, the average has been calculated. And if we click on OK, a new column is generated, or a new variable is generated, which has the overall mark or the percentage of each student achieved in the exam. So here now we have 76 variables and an overall exam marks. So, and we want to identify and determine which questions are good and which question is bad using the point biserial correlation. So the next step is to do a point biserial correlation coefficient. Here, as we can see, we have these questions, and we want to find the relationship or the association between question number 1 with the score in it and correlating that with the overall mark. So to determine whether this question is good or bad, whether it is discriminative or not. And we need to do this for all the 76 questions together simultaneously. So each one by one, comparing each questions with the total mark. So we have here 2 variables. The first variable is the item or the questions, which is categorical because it only had a score in it 0 or 1, category 0 and 1, right or wrong, 0 wrong, 1 is right, and the continuous variable, which is the percentage. So here we can use the point biserial correlation coefficient. And the way to do that is to click on Analyze, scroll down to Correlate, then to bivariate, because we are all looking at here by mean 2, variate mean variable, 2 variables, and I'm going to reset this. Again, we have here the 76 questions or items, and we want to correlate each one individual one with the overall mark to calculate the point biserial value or coefficient. Click on Control A to select all the questions with the continuous variable and drag it into the variables. And we're not going to change anything here, keep it as it is, but we make sure that we use here the Pearson correlation coefficient test, as the point biserial correlation coefficient test is based on the point biserial is based on the Pearson correlation coefficient. If you click on OK, an SPSS will generate a correlation matrix for question number 1 to question number 76, correlating this intercorrelation between each items and correlating them with the overall marks. So we are interested in this column here, or sorry, in this row here at the bottom, and on the final column, which is titled as, labeled as overall mark. And again, if we look at the final row here, which says that overall marks, Pearson correlation, and then it's give a Pearson correlation value and significance of that value. Again, for which is again Pearson correlation represent point biserial. For point biserial correlation, the value is from -1 to 1 to +1. -1 indicates it's a negative relationship, and +1 it means a positive relationship. And the higher the value, the stronger the relationship. Again, and for purpose of analysis of this test, for the point biserial correlation, we set the value that anything below 0.15 value for point biserial, the question or the item is poorly designed, or a poor question, or a bad question. Anything above 0.25 is a good question, and anything higher, it is a very good question. However, simultaneously, we need also to look at the statistical significance. Anything below, any value for p-value for the test below than 0.05, then it is statistically significant and the correlation value is significant. In the first example here, we can see that the correlation between question number 1 and overall mark is 0.22. That's considered to be fair question. However, it failed to be statistically significant, so we will consider that questions probably considered to be a bad question. Again, the same thing for question number 2. The p-value is 0.36, so it is less than 0.05. Again, this question is not statistically, the value for it is not statistically significant, so this question is also a bad question. However, for question number 3, the p-value is 0.029, which is less than 0.05, so it is statistically significant, and the correlation coefficient is 0.35. This is a really a good question that can discriminate between students. Again, a fourth question is 0.5. This is a very good value or coefficient, and the statistically significant. The fifth question is 0.7. The value for the coefficient is 0.76, and this is really a very high value. So this is really a very, very good question. And the sixth question here, as we can see, the point biserial correlation coefficient is very close to 0, so it's 0.054. Anything that is close to 0 or 0 is indicate that the question is not discriminating between students, so it is not a good question, so it is a bad question. Meanwhile, also the value for the there is a statistical significance is greater than 0.05, so this question is really a bad question, and so on and so on and so on. So this is the way to determine which question is good and which question is bad. And if I want to save or export this table, which I'm going to do, and I'm going to export the data, the table or the outcome for the statistical analysis for the point biserial into either Excel file or Word documents or PowerPoint or even as a PDF. And I'm going to export this table here, the correlation matrix, as a Excel file. And the way to do that, click on the table and then right click on export, and then another window will pop up, and I'm going to select Excel 2007 and higher, and I'm going to call it again Point Biserial, saving it, and I'm going to keep the tick for open the containing folders once the file is exported. If I click on OK, it says that it already exists, so I'm going to overwrite it. So the file is exported into the Excel in a format of an Excel file which have the correlation matrix in it, and in this occasion I am only interested in this row. So what I'm going to do is I am going to select the rest and delete it, but I'm going to need, I'm going to keep the question number 1, but I'm going to questions or items, and I'm going to delete the rest. So I'm just only interested in the correlation between the questions and the total marks. Let's make sure that I have everything here set up correctly. So if I right click, select, and then right click and delete, and then click on OK, I will have here the correlation between questions and the value of the correlation and the significance. So I'm going to get rid of the first column and get rid of the last column as it is the number only, and I'm going to rename this, instead of Pearson correlation, Point Biserial, as it is based on Pearson correlation. So I have here the Point Biserial for every individual questions in your exam paper, and I'm going to get rid of this column as there is no need for it. So we have the p-value and the value for the coefficient. So anything with statistical significance and a higher value indicate that the question is good, and anything below it is bad. Here there is an interesting observation, I need to mention it. In one of the data here, let me look for it, minus. There is a minus Point Biserial. Minus indicate that high performing students are answering the question wrongly, and low performing students are answering it correctly. So in this case there is something wrong with the question, and it's the best way is to remove the question and replace it by another question. So this is one of the benefits of doing discrimination analysis, item discrimination, using the Point Biserial correlation coefficient, as it will highlight the question, which question has problem in it, or which question is bad and which question is good. Again, I could also take this data here, copy all the 3 columns or just the 2 columns here. I'm not interested in the first. Copy, and then I had this data in a Excel file. I could also here I have it here somewhere in exam question. I could add it to the data I had already for this exam result, and I could add the Pearson correlation here at the end of the either in columns or in row, and I do prefer it in row here. Again, as for every question biserial correlation, this is question number 1, and this is the point biserial value, and this is the significant value or the p-value for the question. So in this way, I had shown you how to determine which question is good and which question is bad based in exam, based on item discrimination and analysis using the point biserial correlation coefficient.